Great. So, so we have this question, right? Yeah, we have this question. For the following total revenue, total cost function of a firm, can we determine the level of output at which the firm maximizes its total profit? So just there, we know that profit, right? We know that profit is just the difference between total revenue and total costs. Yeah, that is profit. But for us to find the level of output at which the firm is going to maximize its total profit, we have to equate marginal revenue to marginal cost. Okay, so we have to equate marginal revenue to marginal cost. So that's our target now, is to find those two equations. Alright, is to find those two equations. Assignment 1, question 4. Question 4. Great. Yeah, so that's our target. In case you're interested on like in how we reach at this conclusion, or we're saying that we have to equate marginal revenue to marginal cost, the analysis is, if we want to get the marginal profit, right? If we want to get the marginal profit, it means that we are going to differentiate the total revenue function with respect to Q, and we are also going to differentiate the total cost function with respect to Q. We know that since we have differentiated the profit function, the profit function, we know that this should be equal to 0. What does this mean? This means that the change in total revenue due to change in output minus the change in total cost due to change in output should be equal to 0. You see that? Meaning that now we can just get this guy, the change in total cost due to change in output, on the other side of the equation. So this would be change in total cost due to change in output. Now we know that change in total revenue due to change in output is marginal revenue, right? And the change in total cost due to change in output is marginal cost. You see? So we are saying that for us to find the profit maximizing outputs, we should equate marginal revenue to marginal cost. So that is our goal, to equate marginal revenue to marginal cost. Great. So let's do that. Can we equate the two? Yes, we can. How? By first finding the marginal revenue and also the marginal cost functions. Okay. Yeah. So now, since we've been given the total revenue as 22Q minus 0.5 Q squared, okay, so this 1 over 2 is 0.5, right? This 1 over 2 here is the 0.5. How do we get the marginal revenue? Let me just emphasize, just for the last time, the word marginal, every time you see the word marginal, just know that there's a function somewhere that has to be differentiated, or there's a function somewhere that was already differentiated, right? So since we want to get the marginal revenue, it means that we have to differentiate the total revenue function. Alright, so we have to differentiate. So please, marginal, just know that you have to differentiate something, or check properly something has already been differentiated for you. Okay, so please, we are preparing for an exam. Okay, so therefore, to get our marginal revenue, we have to differentiate the total revenue function with respect to Q. Alright, so marginal revenue therefore will just be the derivative of the total revenue function with respect to Q, which means that we have to differentiate this term, that, with respect to Q. Now, let me just do this one more time for the last time. Differentiation. Okay, differentiation. We want to differentiate 22Q with respect to Q, right? We want to differentiate 22Q with respect to Q. How do we differentiate this? First thing first, every time we are differentiating, okay, every time you are differentiating, pay attention to the exponents. What are exponents? The powers. Okay, so pay attention to the powers. So the 22q, the q there is raised to just a power 1. Okay, and how do we do with this? You get that power there, the 1. Let it multiply with the 22 and also with the q. From the power of the q, you are going to remove a 1. So this will be 1 times 22, where this 1 is that power there. It's going to drop when you multiply by 22. Multiply this again by q. Now, since we are differentiating with respect to q, from the power of q, can we subtract a 1? And the power of q is 1. So it's going to be 1 minus a 1. That is just the 22q. How about the next part, the negative 0.5 q squared? This time around, the power is the 2. So that 2, let's drop, multiply it by 0.5, like that. Okay. Then multiply this by q. Since we are differentiating with respect to q, and our q is raised to the power 2, from the 2 there, which is the power of q, can we subtract a 1? Okay, so that is the way we differentiate. Okay, that is how we differentiate, meaning that the marginal revenue function is just going to be 1 times 22 is 22, right? Now q to the power 1 minus 1, 1 minus 1 is a 0. Anything raised to the power 0 is a 1, meaning that where there is q to the power 1 minus 1, that whole thing there, the q to the power 1 minus 1, is just going to collapse to 1, which means that we'll be multiplying this 1 times the 22 times the 1, giving us just a 22. We go to the next side there. Negative 2 times 0.5 is just a 1, right? So it will be 1 times q to the power 1, which is just going to be q. So therefore 22 minus q is our marginal revenue. Alright, so that is our marginal revenue. Next is to get our marginal cost, and we get the marginal cost from the total cost function. We have to differentiate the total cost function, right? So the first term there is 1 over 3q to the power 3, right? So that 3 there, the power for q, will drop. So that would be 3 multiplied by 1 over 3 times q to the power 3 minus 1. Okay, so I'm showing you all the steps just for the sake of cases. Okay, then again minus, let's go to the second term. The second term is minus 8.5 q to the power 2. That term there the power is 2, so the 2 will drop. We're going to multiply that by 8.5 and multiply it by q. From the power of q, which is the 2, we're going to subtract a 1. We go to the other part, the 50q. That there, the q is raised to the power 1. Okay, so it will be 1 times 50 times q. From the power of q, which is a 1, we subtract a 1. The last part is 90. 90 is a constant. The derivative of a constant is 0. So in short, that 90 is not going to have it's not going to affect our analysis. We're just going to keep it as a constant like that. So the derivative of a constant is 0, which means that differentiating the 90, we're just going to get a 0. So don't even add it like plus 0. It's as good as nothing. Okay, so therefore our marginal cost is, now from here we're mathematicians. We know that 3 and the 3 down can cancel. Okay, meaning that you are just going to have the 1 times q to the power 3 minus 2, but 3 minus 2 is, so 3 minus 1. 3 minus 1 is a 2, which means that you're going to have q squared, then minus 8.5 times 2 is 17. Okay, q, we put our q, because 2 minus 1 is just a 1. And then the last part will just be plus 50. Why plus 50? It's because we have got like the q is going to be raised to the power 1 minus 1, and 1 minus 1 is 0. Remember, anything raised to the power 0 is a 1. Okay, great. So now we have the marginal revenue and the marginal cost. These are the two functions that we are looking for. Yes, madam. Yes, madam. Yes. Which is what has been done, right? Or maybe maybe I'm not understanding the question. Try to rephrase the question. Uh-huh. For total revenue. Yes, yes. It's yes. So this negative 2, right? We are going to multiply it by the 0.5, which will give us a -1. You see that? And then we are going to multiply that's this -1 times q, this q, which is raised to the power 2 minus 1, and 2 minus 1 is just a 1, which means that it's more like we're having -1 times q, which is just negative q, which is this that part there. Great. That's great. Let me just admit someone. Okay, great. So now we have got those two functions that we are looking for, the marginal revenue and the marginal cost. Now the next thing is just to equate, right? Okay, let me try to speed up a little bit. So we have the marginal revenue. So in short, what we want is to do this. Marginal revenue should be equal to marginal cost. Our marginal revenue is 22 minus q, which should be equal to our marginal cost. What is our marginal cost? Our marginal cost is this guy. Okay, so this is equal to q squared minus 17q plus 50. Great. Now, can we make this whole thing as one equation? Okay, we need to make this whole thing as one equation. So what we're going to do is we're going to get the 22 minus q, we're going to take it to the other side, so that it should come this side. It should, let's transpose. Okay, so which means that we're going to have q squared minus 17q plus 50. Then now we're going to say this 22 should go the other side, so it will become minus 22. This negative q should also go the other side, so it will become plus q, like that. Okay, now can we simplify this? Yes, we can. So q squared minus, now look at this, can we put these can we add and subtract, right? Can we add and subtract? So we're going to have minus 17q plus q plus 50 minus 22, like that. What we are doing there is just putting them close to each so that we can easily simplify. Great. Okay, so this will just be q squared minus, now negative 17q plus q, the answer is just minus 16q. Okay, like that. Okay, then the other part is 50 less 22, which will be positive 0.8. Now this is equal to 0. When you have such a function where the highest power is 2, just note this is what is called a quadratic function. A quadratic function. Quadratic function. Now how do you solve a quadratic function? It's very easy. How? Because use a formula. So to find the value of Q, we are going to say negative B plus or minus the square root of B squared minus 4AC everything divided by 2A. So this is the formula that we use. Okay, that is the formula that we use. Now our A is the number right before Q squared. There's a number there, there's a 1, so that will be our A. Okay, so our A is just a number right before Q squared. Our B is this, the negative 16, that's our B. Our C is the 28, the constant. So what you do is you just get those numbers there and plug them in the function there, in the formula there. Then you use the calculator and solve, right? Great. So our Q is going to be equal to, now we are saying that the formula is negative B, and our B there is already negative, is negative 16. So that negative and this negative will cancel each. They will cancel each other, meaning that the answer that we're going to put here is just 16, positive 16. Get me right? If our B was positive 16 already, if it was positive, then he would have put negative 16 here. Why? Because that positive times this negative in the formula, the answer will be negative. Okay? The moment you make just one mistake here with the signs, everything will collapse. Okay, so please just pay attention to the signs. Negative times positive, the answer is negative. Positive times positive, the answer is positive. Which other one? Negative, positive. Okay, then plus or minus the square root of, what is our B squared? Our B is negative 16, right? So now please get me right on this point as well. Look, the way you put a negative, okay, the way you put a negative here, don't say negative 16 like this, squared. Why? Because when you go on the calculator and punch this the way it is here, negative 16 squared, it's obvious that you are going to get a negative answer. And one thing you should know, there is no answer, there is no square root for a negative answer. So if you try to punch the way I've written this, negative 16 squared, you're going to get a minus 256, which will just jeopardize your answer. Okay, so how do we do this? You open the brackets, put the negative 16, you close, then you square. Like that. That is our B squared. Then after B squared, the formula is saying, can we put minus 4? Then we multiply A times C. Right? Our A is a 1. 1, that is before Q squared there. So there is a 1. We are multiplying this 1 times the C. What is the C? The 28. Then what do? We divide everything by 2 times a 1. Because our A is a 1. Great. What's next? Just simplify this guy. So it will be 16 plus or minus. Now when you go on the calculator, you open the bracket, you put negative 16, you close the bracket, you square that, you're going to get positive 256. So it will be 256 negative. Okay? Then now, with this, you can punch everything, assuming that you're using a scientific calculator. Okay? You can just punch everything there. Now when you do minus 4 times 28, you should get 112. Like that. You are dividing this whole thing by a 2. You see that? So Q will be 16 plus or minus the square root of, now when you do 256 minus 112, you're going to get 144. You are dividing this by 2. You see that? Again, you go back to your calculator. Punch, the square root of 144 is 12. So this will be Q is equal to 16 plus or minus, right? The square root of 144 is 12. We are dividing this by 2. Now, look at this. There we have plus or minus, which is telling us that we are supposed to split this into 2. One part should have a positive, the other part should have a negative. Meaning that our Q is equal to 16 plus 12 over 2, or our Q is 16 less 12 over 2. You see that? So our Q can either be 28 over 2, or our Q can be 4 over 2. Meaning that our Q has got two values, a 14 or a 2. You see that, right? Now, when you reach this point, every time you are dealing with a quadratic function, okay, every time you're dealing with a quadratic function, you're going to get two values. And it's obvious that unless otherwise, if they are equal, it's okay, because that means that is the answer. But if you find that one is higher than the other, like the case here, you always go for the higher one, because the assumption is that this firm should produce more of this particular output, because the more it produces, the more it sells. The more it sells, the more revenue will come in, like in the firm, will come into the business. So always go for the higher one. In an event that you have got two answers, one is positive, one is negative, go for the positive one. Why? Because you cannot produce a negative output. So our correct answer is 14, meaning that the profit maximizing output is 14 units. Okay, so that is the profit maximizing output, 14 units. Okay, we have the 14 units there. So let me just get feedback, maybe from 2 people, then we can carry on. Yeah. Yeah, how is it so far? Oh, perfect, Madam Shabi, that's great. Yes, Mr. Msonda, carry on. Let's go to the first one first. You are saying the first one is how we go to 0. Here where it's Q squared plus 16Q plus 28 is equal to 0. Every quadratic function will be equal to 0. Great, that's okay. Yeah. Yes, where? Yes. Great. Okay, that's okay, sir. So the thing is this, a quadratic function should give you two answers. Okay, it should give you two answers. Why? It's because we are saying in this case it's a 16 plus or minus a square root of 144, then everything over 2. So when you simplify that, we're going to have Q is equal to 16 plus or minus 12 over 2. So now, after doing this, we come and split this. Okay, we come and split. So, remember it's 16 plus or minus 12. Which means that one side should have a plus. Then the other part should have a minus. Because it's plus or minus. So no wonder we've got 16 plus 12 over 2. Or Q is equal to 16 minus 12 over 2. So it's because of got plus or minus that we've got these two sides, where one is going to have a plus in between, the other one is going to have a minus in between. It's because of the nature of the formula, plus or minus. Perfect. Okay, is there another question before we can forge ahead? Yes, Mr. Mpanza. Assignment 1, question 4. No. Question 4. This comma 1 for finding the question 4. Assignment 1, question 4. Now from those we want to find the profit maximizing output. So guys, you are late. So we've already done what is supposed to be done. So you have to wait for the recording for this part. Yeah, I know you follow. Okay. Use what right. Great. Okay, great. So now since we've said that the profit maximizing output is 14, right? Since the profit maximizing output is 14, now we have to use the 14 to find what profit this firm will realize at the end of the day after producing 14 units. You see that? Yeah. So the other part now for B, this one you have not missed, Mr. Pan. Now we're together now. Determine the value of maximum. What am I saying? First thing, tell me the level. Okay, yeah. Determine the value of maximum amount of total profit of the firm. So we want to find profit of the firm given that output is 14 units. Right? So given that Q is 14 units, what we want is to find profit. So how can we find profit? We know that profit is just the difference between total revenue and total cost. Right? So therefore, our profit will be equal to, go back to the total revenue function. You know, our total revenue function was 22Q minus 0.5 Q squared. This is just the total revenue. Now from this function, can we subtract the total cost, which is 1 over 3 Q to the third power minus 8.5 Q to the second power plus 50 Q and then plus 90. Okay, so this one I won't solve. I'll just tell you what to do so that you can dedicate time to the other question. Plus 90 like this. So what you do is this, since Q is 14, right? Just substitute. What there is Q here, put 14. What there is Q squared there, put 14. Then you square it. What there is Q to the third power, put 14. Square. Raise it to the third power. Even here, put 14. Even there, put 14. Find the answer. If my calculations are correct, you should have something like a 166 as profit. So just put it there. I don't know if this is correct. Remember, we looked at this another time. So the key is just put the values there and on the calculator and then punch. Again, find the value of profit. So that is what you do. Okay, but just get me right. This does not mean that every time they're asking you to find the profit maximizing output, then you have to use, or then you have to find a quadratic function. No, it's because of the nature of the way our functions have been structured that we've ended up using the quadratic or finding the quadratic function. Okay, yes. So you only do what you've done if you've been given a quadratic function. If functions are linear, you will not have any quadratic function. Okay, I'm sure that is fair enough. Can we move to the second question? Okay, great. Let's move to the second question. Question 6 now. Question 6. Question 6 is about Oh, we did question 4, right? Oh, sorry. Let's go to question 5. The goodness is that question and this question are related. That's the goodness. Okay, let's go to question 4. Oh, 5. Sorry, 5. So with this one, the logic is the same. For the following profit function, determine the level of output of each commodity at which the firm maximizes its profit. This one is also the simplest, as long as you know how to do partial derivatives. So the function is profit is equal to 144 x1 minus 3x1 squared negative x1 x2 minus 2x2 squared plus 120 x2 minus 35. Great. Determine the level of output of each commodity at which the firm maximizes its profit. This one is simple. How? Because you just have to find the partial derivative of the profit function with respect to x1, then you also find another partial derivative of this same function with respect to x2. In short, you have to differentiate partially this function with respect to x1 and x2. Then you solve the two functions simultaneously and get their values. Okay, so even with this one, I'll solve the first part for getting the quantities x1 and x2. For the second part, where you have to find the profit, it's just to get those values, you put them back in the profit function and punch on the calculator. Okay, assuming that you have a scientific calculator. Please, if you don't have a scientific calculator, find means and ways. Find means and ways of having one. Yeah, if you're writing from Unza, if you don't have a scientific calculator, hit me up. I can give you mine. Like so that you write an exam with one hat. Not you go there, the Kinko calculator is performing. The BP will just shoot. Boom. Okay. So yeah, let's determine the output of each commodity at which the firm will maximize its profit. We are saying that we should just partially differentiate with respect to x1 and x2. Great. So how do we partially differentiate? Now here, listen to this. The concept of partial derivatives means that you are going to, let's say we are trying to partially differentiate this function with respect to x1. You are only going to differentiate those terms where x1 is featuring. Meaning that we are going to differentiate the first term, the second term, and the third term. We are going to keep this term, the other term, and this other term constant because there is no x1 there. So that is the concept of partial derivatives. You just partially differentiate a given function with respect to that particular variable under consideration. You keep all other variables constant. Great. Let's do this. Yes, we can. First part, 144x1. 144x1. We want to differentiate that term with respect to x1. This x1 is raised to the power. There's a power there, even if it's not there, but it's there. Yes, sir. You don't need to show, sir. You don't need to show. I'm showing so that maybe there's someone who's seeing this for the first time, that maybe they can follow. But we know that when you're solving, just go straight to the answers. You see that, huh? Yeah, because we know that. We'll be able to tell that, okay, what Mr. Mpanza did here is this. Yeah. But yeah, just for the sake of maybe there's someone who is, seeing this for the first time, let's help such a one. Yeah, so the power there is a 1. So the 1 will drop, we'll multiply it with 144, we'll also multiply it with x1, then we're going to remove a 1 from the power of x1. Go to the second part. The second part is minus 3x1 to the power 2. So as usual, that 2 there will drop. We'll multiply this by 3. We'll also multiply it by x1. Then from the power the 2, we're going to remove a 1. Okay, so I'll be fast now. Okay, minus. Let's go to the other part there. Minus x1, x2. Now, listen to this. x1 and x2 are multiplying. This term is multiplicative. So we are going to differentiate with respect to x1 and put back x2. Okay? So x1 is raised to the power 1. As usual, that power should drop. So it will be minus 1 dropping. We are multiplying this with x1. But this x1 is now going to be raised to the power 1 minus 1. We put back x2. We equate everything to 0. Why? Because every time we differentiate a function, the slope of that particular function is 0. That is what it means. Okay. So we know that if you simplify this whole term here, you just have your 144. Okay. Why? Because the x1 to the power 0 is a 1. Anything to the power 0 is a 1. Then the next step is just to be the next part there will be minus 6x1. The last part will be a minus x2. This is equal to 0. So can we call this equation 1? Okay. So let's call that equation 1, the derivative with respect to x1. The second step, let's get the derivative with respect to x2. So look at this. Since I've already we've already discussed how we differentiate, right? So for this one, I'll just go straight to get the final answers. Okay. So with respect to x2, x2 is present there, x2 is also present there, and it's also present there, like that. So if I differentiate that term minus x1, x2 with respect to x2 this time around, right, I'll just get my minus x1. Okay. And then the next term there, negative 2x2 with respect to x2 will give me minus 4x2. And then the last term will just be positive 120. This should also be equal to 0. And let's call this equation 2 like this. So if you don't know how to differentiate, feel free. Okay, you inbox me, I share a recording we did some time back on differentiation. It's for your own good. Okay, great. So we've got two functions, two equations. What we want is to find the value of x1 and x2. Since we've got two equations, we know that we can solve these equations simultaneously. Right? We can just solve them simultaneously. How? Well, let's start with equation 1. Let's rewrite equation 1. Let's get this. All the x's all the terms with x's on the right hand side. So that we've got 144 is equal to 6x1 plus x2. Okay, we do the same with the second equation. We get these terms with x's, we take them on the other side, so that we're going to have 120 is equal to x1 plus 4x2 like this. So now it's easy for us to apply the laws of simultaneous equation. If we want, we can use the matrix method. If we want, we can use the substitution method. If you want, we can use the elimination method. The choice here is yours. You go with it, with whatever you're comfortable with. If matrix method works well, apply it. Carry on, use the matrix method. But for the sake of simplicity, let's go with the substitution method. Okay, let's go with substitution method. Great. So let's do this. From this, even just from the first one, it's okay. From the first one, this Kamagai equation 1, let's make x2 the subject of the formula. So that will be 144 minus 6x1 is equal to x2. You see that, right? We've made x2 the subject of the formula from equation 1. From equation 1, we've made x2 the subject. We've just taken this guy, this guy to the other side, so that we can just have x2 on the right hand side, meaning that x2 is equal to 144 minus 6x1, like that. Now what does this mean? This means that, and just let me just emphasize, if you have used equation 1 to make either x1 or x2 the subject of the formula, don't replace x2 in equation 1 again. Replace x2 in equation 2 in the other function. Okay, I believe that's clear. Okay, so since we've made x2 the subject of equation of the formula from equation 1, we are going to substitute x2 in equation 2, not equation 1. Don't make that mistake of replacing it back in equation 1. Okay, great. So our equation 2 is 120 is equal to x1 plus 4x2. So now we know that where there's x2 here, we can put that 144 minus 6x1. You see that? So therefore 120 will be x1 plus 4 open brackets. Where there's x2, we can put 144 less 6x1. You see that? So therefore 120 will be x1 plus now the next thing is just to open the brackets. So when you multiply 4 times 144, you're going to get 576 minus 4 times 6 is 24. So 24x1, like this. You see that? Great. I'm sure you can see that these things are not difficult. They are not difficult. Okay, great. Now look at this. You have got x1 there. You also have got this term minus 4x1, meaning that you can do with those two. Then let's get the 576 on the other side, so that we have got 120 minus 576 is equal to, now when you do x1 minus 24x1, it's more like you're saying 1 minus 24, which will give you minus 23x1. Okay, you see that, right? Now 120 minus 576, you're going to get negative 456, like this, is equal to negative 23x1. You want to make x1 the subject, just divide by negative 23, even here by negative 23. You cancel, so that your x1 is negative 456 divided by negative 23, which will give you something like a 19.8261. So let's just make this a whole number. It will just be 20, which means that for x1 we have got a total of 20 units. For x1 alone, we have got a total of 20 units, like this. Okay, so that is just for x1. That is just for x1. The work is not done. We need to also find the x2. So remember that somewhere we made x2 the subject of the formula. We have a function somewhere that is describing x2 units that can be produced. You get that? So that function is that one in red there, the one we've circled in red. So our x2 is 144 minus 6x1. So therefore our x2 is 144 minus 6. Where there is x1, we put the value that we found, the 20. We put the 20 there. You see that? x2 will be 144. So when you do 6 times 20, you're going to get 120. 6 times 2 is 12. Put the 0. So you have got 144 minus 120, like that. Right? So now when you do the subtractions, you're going to get 24 units. So x1 is 20, x2 is 24. Those are the profit maximizing units that can be produced by this particular thing. Right. How is this? How is that, Mr. Msonda? If you can hear me. Mama? Okay. Great. Just find time. Try to give it that extra attention, especially that we've gone through it together. So the key is, yes, Madam Senga. So the thing is this. Let's say if we give this, for argument's sake, let's assume that we've given these 10 marks just for this question. First of all, we'll look at whatever you are doing. We'll pay attention to all the steps, the key steps, of course, how you've differentiated, how you are dealing with the signs, and that's the mistake that most of us, that's the mistake that I think that's a disease that we have to cure ourselves of. Signs. In mathematics, in this particular course, a negative is very important. A positive is very important. So paying attention to all those details. So we don't go for the final answer. We look at whatever you are doing until the last part, because we don't want to disadvantage someone. Let's say someone is like all the steps are correct, but maybe when punching the last answer, they have just made a mistake with punching. You see that? So if we go for the final answer, then we'll be killing people. So we go for the steps and the final answer. Actually, the final answer does not carry many marks. Yeah. Okay. Great. So please find time. You will be fine. Hello. The question itself will give you direction. Mr. Panza, you don't need to order. Yeah, so the question will give you direction. When you look at the question, you should know that, okay, here I have to do this. Actually, the question itself will tell you, the question itself will literally tell you indirectly that you have to do this. So in this case, we've not been given the total revenue, we've just been given the profit function. You see that? So you know that, okay, I've been given the profit function. In this profit function, there are two types of goods. There's good 1, there's good 2. How can I find the values? Well, it's by differentiating the profit function with respect to these two goods, good X and good X1 and good X2. Then next thing, after differentiating, what do? You have got 2 equations. How do you solve 2 equations? How do you solve 2 equations where each of those is containing the 2 variables you're looking for? You have to apply simultaneous equations. You can solve the 2 simultaneously. But when it comes to that particular point, the method you use is all up to you. That is your case. That is your choice. If you're okay with the matrix method, go ahead, use the matrix method. If you're okay with elimination, eliminate one variable, deal with the one that is remaining. If you're okay with substitution, carry on with the method you've used. There the choice is yours. So the question will give you direction. So what is needed now is in the next, I don't know if it's 24 or less than 24 hours, the target is, on your own or as a group, you shushana. The more you shushana, the more you know what to do. You see that, right? So yeah, in short, let's just keep on revising. Let us not slumber. Yeah. Mr. Mpanza, that's okay, right? Great. So for the second part, I will not solve. The second part is saying determine the value of the maximum amount of total profit of the firm. For this one, we know what x1 is. We also know what x2 is. So just substitute. Where there's x1, put the value. Where there's x2, put the value. And use a scientific calculator and solve. Okay? Use a scientific calculator and solve. Not any other. Could be giving you very funny answers. Something where you finish the exam, go out, now you start discussing with your friends. My friend, what was the answer there? Your friend is telling you this answer. Yours was direct opposite because of the calculator. So please, let's sacrifice and get scientific calculators. Great, which means we can go to question 6 now. Elasticity. We can handle elasticity. Okay, let's move. What's question 6? Suppose the demand function for a firm's product is given by this function here, right? Yeah, where Px is the commodity price, Py is the price of a related commodity, M is per capita disposable income, A is advertising expenditure. The price of good X is 10, the price of Y is 4, income is 20,000, A is 250. Great. Determine on-price elasticity of demand and state whether the demand is elastic, inelastic, or unitary elastic. Now listen to this. With elasticity, we just want to know how a change in a commodity price will affect the demand for that particular commodity. In short, just the percentage change in the quantity demanded due to a percentage change in the price. That is with the price elasticity of demand. Okay, that's with the price elasticity of demand. It's just the percentage change in Q due to percentage change in P. Okay, yeah, that's with the price elasticity of demand. Now in our case here, we have the question is saying determine the own price elasticity of demand. Okay, on price elasticity of demand. Now listen to this. If you want to find the on price elasticity of demand given a question like this one, I think last time we discussed up to like differentiating. We said we can differentiate the demand function, okay, with respect to Px. Okay, so what you do is this: after differentiating, right, multiply by, okay, so I think this is the component that I forgot to discuss with you last time. Okay, yeah, so for this question, if you noticed, we are giving half marks because of this. Okay, so it's supposed to be change the partial derivative of the demand function with respect to Px multiplied by price over quantity. So this is the full formula. Okay, so this is the full formula. In short, that is how you do the full formula for elasticity. So please write this one. Just write it in case of emergencies. In case you find yourselves handling a question similar to this. So the price elasticity will be equal to, okay, will be equal to the derivative of the demand function with respect to price of x, which is this part, okay, then you multiply by the initial price and initial quantity, meaning that we need to find initial quantity. First thing first, so quantity demanded has been given as 3 minus 0.5 px minus 2.5 py plus m, then plus 2a. You see that, right? So therefore our q will just be 3 minus 0.5 of, we've been told that the price of x is 10, so put 10 there, minus 2.5 py, the price of y is 4 there, put 4, plus income is 20,000, yeah, then plus 2 times a 250, like that. So in short, first thing first, find the quantity that will be demanded at that particular at those values there. Okay, so get your scientific calculator, punch. We have got that minus this times that plus this, then plus that. So assuming that you have done the correct calculations here, I'm getting a 20,488 as the quantity. Okay, as the quantity. Okay, let me just do it one more time to be sure. Yes, I'm getting 20,488 as the Q. So now it is after getting the value of Q that you apply the formula now. Okay, price elasticity easy. So we differentiate our demand function with respect to Px, then multiply by a price of good X over quantity of good X, like this. So this is the full formula. So in an exam, let's go with this formula here. Okay, it's going to be handy if we find a question similar to this one. Okay, so now first thing first is to get this part, the derivative of the demand function with respect to P. Okay, with respect to P, you see that, right? So when we differentiate with respect to P, which means that it's just that part there, the minus 1 over 2 px. So we are going to differentiate this part 1 over 2 px with respect to px. So please get me right, you are not differentiating with respect to x. You are differentiating with respect to price of good x, which is this whole term here, the px. The px there is one thing. It's not like there's p and then there's x. It's a price of x, which is, let's say, 2. You see? So it's price of good x. So don't make that mistake of saying I will differentiate with respect to x, then you find your final answer, let's say minus half p. Not like that. Okay, not like that. So yeah, differentiating the half px with respect to px, we know that since it's 1 over 2 px, well, this px is raised to the power 1, so it will be 1 multiplied by negative 1 over 2, which will be multiplied by px. Since you are differentiating with respect to px, from the power of px, which is a 1, we are going to subtract another 1. So this will just collapse to minus half, which is minus 0.5. You see that? Like that. So for the first part there, okay, for the first part there, we are going to have a minus 0.5, which is just this. Now the formula is, after finding the change in Q due to change in Px, can you multiply this times the px divided by qx. Now px is 10. Okay, we are going to put our 10 there, divided by qx, the 20,488, like that. Okay, so you go and use your scientific calculator. You divide that, then you multiply it by 0.5. Okay, so EP will be 0.1232 negative. Okay, assuming that I've done it correctly, let me do it again. 2488. It's giving me this divided by that. Yeah, it's giving me 0.00, like 244, something like this. Now, you know what? Getting this answer here is one thing. Understanding this answer is another thing. Because it is after understanding this answer that you'll be able to answer the question. Okay, now listen to this. If you have calculated your value of elasticity and your value is lying between 0 and 1 in absolute terms, okay, what do I mean by absolute terms? I mean that after introducing the modulus, okay, if after introducing the modulus is this, like the way this answer is negative, right? Introducing modulus means you're just putting these bars, open bar and a closed bar. These bars transforms this to a positive number, which means you will now be dealing with 0.000244, like this. So if you have calculated your value of elasticity, and that value is lying between 0 and 1, like the case is here, this is 0.00024, which means that this thing is lying between 0 and 1. Then it shows that demand for this good is inelastic. Now what does this mean? This means that the demand for this particular commodity does not respond to changes in price. In short, an increase in the price of this particular commodity will not reduce demand. Okay, even if you have increased the price of this particular commodity, let's say by 1 unit, the demand will reduce by 0.0024, which is so minute, so the margin is very small, which means that the demand for this particular commodity is inelastic. So inelastic means that the demand is not elastic anyway. It's the opposite of elastic. Okay, great. The other possibility is a case where you have solved your elasticity and the answer is exactly 1. Let's say after doing our mathematics here, we find that the answer is exactly 1. What does that mean? It means that demand is unitary elastic. Now, with unit elasticity, there it just shows that you increase the price, let's say by 10%, right? Quantity demanded will also fall by 10%. It's unit. It's going 1 for 1. Whatever you do on price, you increase price by, let's say, 5%, demand will also fall by the same margin, 5%. No wonder it's unitary. Okay, and then the last possibility is a case where you have calculated your value of elasticity and it's higher than 1. Please, when I'm saying it's equal to 1, it's higher than 1, it lies between 0 and 1, I mean in absolute terms. After introducing the modulus, check your answer. Is this answer higher than? Not that after calculating without introducing the modulus, then you come and apply these rules. It's obvious that your conclusion is going to be jeopardized. If you want to work with negatives, get me right, okay? If you want to work with negatives, it's like this. it's a case where you have this now. This means that your value of elasticity is lying between -1 and 0. Okay? That is if you want to work with negatives. If you don't want to introduce the modulus. If you want to work with just the way the answer is in this case, negative. If the answer is lying between -1 and 0, and I think you know that 0 is better than -1. Okay? So if your answer is lying between -1 and 0, then demand is inelastic. Okay? Inelastic, which when you introduce the modulus, this will be between 0 and +1. Okay? The second possibility is a case where your answer is exactly -1. So this means that you are dealing with unitary elasticity, which if you had introduced the modulus, this will be +1. So anyways, the point I'm trying to say is the analysis really does not change whether you are dealing with negatives or maybe you have introduced the modulus, you are not dealing with the positive. The analysis, the conclusion should be the same. Okay? And of course, the last case is the case where, so let's start with the positive side. This thing that I've written here. If your elasticity is greater than 1, this means that the demand is elastic now. It's elastic. This means that you increase price, let's say by 1%, the demand will fall by more than 1%. Okay? Because the value is greater than 1. If you want to work with negatives, the same. It's a case where your elasticity is less than -1, which means it's more negative than -1. Let's say it's -1 point. Okay, then it means that demand is elastic. So whether you work with a negative side or you work with a positive side, the conclusion will be the same. So now, looking at our answer, determine the on price elasticity of demand and state whether demand is elastic, inelastic, or unitary. Well, we've seen that this answer is between, in absolute terms, right? Is between 0 and 1, which means that demand is inelastic. So demand for good X is inelastic. Okay? So please pay attention to those gymnastics there. Okay, how is this? Let me get your feedback. Oh, okay, yes, sir. Mm-hmm. 10 divided by 20,488, it's giving me something like 4.88. Then it's raised to the power times 10 to the power negative 0.4. Is that what you're getting? Mm-hmm. Aha, so look at the far end there at the right, Pamwamba, there is times 10 to the power negative 0.4. You see that? That means that before the point, okay, before the point there are 3 zeros. The fourth number is the 4. So now this same number, right, multiplied by 0.5, what are you getting? Yeah, just the way it is. Just either, it's okay. Great. So so I've just converted this to that, because it's raised to like times 10 to the power minus 0.4. This shows that there are 3 zeros before a number. So no wonder I've said it's 0.5 0 0 0 3 zeros, then I put the 2, you see that, then the 4 4. No, it's not. It's not correct. You're supposed to convert it. Unless if you tell me that you're going to say 2.44, you're going to write this whole number here, then you also say times 10 to the power minus 4. Which, but that means that your answer is going to be a bit cumbersome. So it's better you convert it to decimals. Yeah. Okay. Great. Another question, please. Mr. Mpanza, are you here? You are here. You don't have a question? Okay, that's great. That's great. Right. Yeah, so that is how we do this. Now, for the second part, determine the cross price elasticity of demand between good X and good Y and state whether the two goods are substitutes or complements. Don't worry. First thing first, let's get the cross price elasticity. Now, we know that elasticity between good X and good Y, which is cross elasticity, that is how we write it. So there's epsilon X Y, which is cross elasticity between good X and good Y, is just the derivative of Q with respect of QX with respect to PY. Then you multiply this by the price of Y over QX. Okay, that's the full equation there. Where PY is just the price of Y. QX is just the quantity of good X at the given values, which we've already found. The 20,000 something. Great, right? So let's get the first part, the derivative of the demand function with respect to PY. Let me just help someone. This term there, that term in the one we've circled in red, this is telling us that we are differentiating partially, right? We are partially differentiating the demand function of good X, which is that guy there, the function. So we are differentiating that function partially with respect to PY. We want to understand how a change in the price of good Y is going to affect the demand for good X. Now, and it's called cross price elasticity. It's because we want to understand how a change in the price of good Y will affect the demand for good X. Okay? It's when I've got two goods, Fanta and Coca-Cola. We want to know how will the increase in the price of Coca-Cola, how is it going to affect the demand for Fanta? It's cross. So that is what that term there, is all about. So now, great. Let's go back to our function. So differentiating the the function there with respect to PY, that term is negative 2.5 PY. We know that anyways this will just be negative 2.5, right? So we've just applied the differentiation there. Again, if you are not if you're still lagging behind on differentiation, please, this is about you and your future. Let me know. I will share that recording we did on differentiation, because listen, you cannot go to write managerial economics minus understanding differentiation. There shall be chaos, there shall be trouble there. So my plea is, make sure you go in that exam, at least you know how to differentiate, because this course is about marginal this, marginal that, marginal this, marginal that, and that is differentiation. So please, if you feel that deep down your heart you know that you're still lagging behind on differentiation, please inbox me. I'll share the recording for mahala. Okay, for mahala. So just inbox me. I'll share the recording Okay, at the end of the day, that's what humanity calls for. Helping one another. Great. How can I share in your inbox when I don't know that you need help or not? It's difficult. You are feeling shy about your future, your grades. It's you against Mr. Chirwa. So yeah, don't feel shy. Okay, don't feel shy. Just let me know. Just let me know. Okay. Yeah, please. I'm pleading because I don't want. I don't want people to repeat this course. Nah. There's no room for that, right? Great. I've seen the message. I'll respond. Determine the cross price elasticity of demand between X and Y and state whether the two goods are substitute or complements. Great. Let's do that. So change in QX, change in PY, you've said that is just going to be minus a 2.5. That is after differentiating that gamma term with respect to PY, right? Can we multiply this with the initial, what is the price of Y? Is 14 divided by, I've forgotten the value for Q. All I remember is it has got 20 point something. Is it 20,488, right? I think so. 20,488. Like this. 20,488. Hey, Lord. Sorry, something where I'm needed somewhere right now. Let me negotiate with this person because I was supposed to meet this person at 18. No wonder my first message was let's meet at 20. And I negotiated to 1830 to 1930, and now it's some minutes past time. But it's okay. Let's finish this question. I think I'll still negotiate with her. Okay. Great. Yeah, let's punch this quickly. So 4 divided by 20,488. 20,488. It's giving me 1.9 something times 10 to the power minus 0.4. Let's multiply this by 2.5. Yeah. So the answer is negative 0.123 then 488.1. Something like this, huh? Something like that. Let me just do it again for the sake of not making mistakes. We've got that here times 2.5. That, yeah, minus. Great. So we have negative 0.004881. So now look at this, huh? In modulus, this is 0.005, huh? After making it correct to 0.005, corrected for decimal places. Now listen to this. With cross price elasticity, right? With cross price elasticity, listen to this. This means that, okay? Oh, let me not even introduce the modulus since this is cross price elasticity. Yeah, it's okay. Now listen to this. With cross price elasticity, this means that after increasing the price of good Y, remember what you should always know is this: percentage change in QX, in this case due to percentage change in the price of Y. This is the one that we are expanding to that thing there. Otherwise the logic is the same thing, change in quantity demanded due to change in PY. So this means that if I increase the price of good Y, the quantity of good X is falling. Why? Because the answer is negative. So just one more clarification there. With the cross price elasticity, you don't introduce a modulus. No. get the values as they are. If the answer is negative, work with it. If the answer is positive, work with it. I'll explain why. Yes, someone's mic is on. Go ahead. Oh, it's off. Yeah. So, yeah. So in this case, this means that increasing the price of good Y reduces the quantity demanded of good X. Look, it's a case where you have increased the price of Fanta. The demand for Coca-Cola is falling. After increasing the price of Fanta, you see that, right? So it's more like these two goods are just complementing each other. You increase the price of good Y, not only will the demand for good Y fall, but the demand for X will also fall. Why? Because due to the fact that the price of good Y has gone up, demand requires that, or the law of demand requires that the quantity demanded of good Y should fall. But what we are seeing is that the quantity demanded of good X is also falling, meaning that the two goods are complements. They are just complementing each other. So you increase the price of good Y, demand for X, demand for X is also falling. Okay, so demand for X is also falling. So this means that the two goods are complements. They are complementing each other. You see that, right? The two goods are complementing each other. Okay, the two goods are complementing each other. Okay, sorry, I was trying to negotiate. Yeah. So you increase the price of good Y, the demand for good X is actually falling, which means the two goods are complementing each other. So they are complements. In short, if cross price elasticity, if cross price elasticity is negative, just not dealing with it, complements. If cross price elasticity is positive, you are dealing with it, substitute. So you can write those two things and you memorize them in case of cases. Okay, in case of cases, if cross price elasticity of demand is negative, then you are dealing with complements. If cross price elasticity of demand is positive, you are dealing with it, substitutes. I think that's helpful. Okay, so that's how we do the. Yes, Mr. Mpanza. So negative is equal to complements. Positive is equal to substitutes. That's okay? Great. Okay, great. Yeah, so it's something like this, it's something like that, It's as simple as that, right? Yeah. Great. So the two goods are complements. Yeah, simple. Determine the income elasticity of demand and state whether good X is a normal good or inferior good. This one is the simplest. With income elasticity, you are just getting the same thing. You are going to differentiate the function with respect to income. Okay, then multiply this by initial amount of income, then divide by Q. Okay, so we know anyways that the thing for M there is just for income is just an M. If we differentiate that will just be a 1. Yeah, so I will just be multiplying this same thing by income, which is, what's the income? 20,000 by 20,000 divided by 20,488. So 20,000 divided by 20,488, it's giving me positive 0.9. 0.76, maybe 2 to 4 decimal places. It's giving me this number. In short, if income, okay, if EI is greater than 1, it's positive. Let me say so. Or let me say so. Let me say this: if your elasticity, if your income elasticity of demand, if your income elasticity of demand lies between a 1 and a 0, okay, which means it's positive. Okay, so if our value lies between 0 and 1, it means that we are dealing with what is called a normal good. So for normal goods, elasticity of income will lie between 0 and 1. Okay, so for normal goods, elasticity of income will lie between 0 and 1. Now, how about a case where this thing is greater than 1? That is a case of what is called a luxury good. Okay, a luxury good. And if your elasticity of income is less than 1, this is a case of what is called an inferior good. Okay, so just to help someone, a normal good is a good where an increase in income will lead to an increase in demand, right? But a luxury good is a good where an increase in income will lead to a larger margin in the demand for this particular good. That is a case of a luxury good. With luxury goods, these ones you buy them to show off. You buy them. Sometimes they're called conspicuous goods. You buy them so that the neighbor can see that you've got money. Okay, that's a luxury good. So the moment you receive that promotion, your salary is adjusted upwards. Hey, boom, you get yourself a Lamborghini. So they can show they can see, right? So the point I'm trying to stress is a luxury good is just a good where a small increase in income will lead to this big margin in demand. So demand will increase by a larger margin. Then inferior good is just an opposite of a normal good. You increase income, you forget about the commodity. So an increase in income reduces the demand. That's the case of soya chunks. You only buy soya chunks when you're poor. Yeah. The more money you have, the more hang you lie on your hammer. It's as simple as that. Okay, so that's I think I did not. Okay, yeah. So in this case, since our answer is lying between 0 and 1, we're just dealing with a normal good. Great. We're just dealing with a normal good there. Okay. Then determine on advertising elasticity of demand. These things are too simple. With on advertising, right? Advertising is represented by the 2 and an A there. In short, that A is for advertising. When you differentiate that with respect to A, you are going to get a 2. You see, you're going to get a 2. Multiply this by, because note that is just a derivative of QX with respect to A, right? So you're going to multiply this by A and like this, just like we've been doing for the other ones. So differentiating that with respect to A, which I believe now you know how to differentiate, you're going to get a 2. Then the value of advertising expenditure is 250. Put your 250, divide this by 20,000, 488 like this. Then you punch using a scientific calculator. 488. This is being multiplied by 2. Yeah, so it's positive. So I'm getting 0.02 here, something like this. What does this mean? Since it's positive, it means that when you're increasing your advertising expenditure, the more you advertise, the more you're increasing demand for your commodity. In short, as you're advertising, more people come to learn about your product. They buy more of your product. So the more you advertise, the more you sell. So that is what it means. That's what it means. Yeah. Then the last part there, derive the equation for the demand curve. This, come on, just do this. Since they've changed the price, they've changed the price of X. PX is now 20. Initially it was what? PX was 10. Get this guy, put it where there is PX there, put 20 where there is PX, maintain PY, maintain M, maintain A, find the quantity. That's what it means. So this one I can't solve, because these are things that we can handle. So how is this so far? How is this? It's okay, right?